Hi everyone. Yeah, so I'll be talking about how can we use ZK-based storage proofs to improve the dRTC meetings for gated token meetings. Okay, so yeah, a little about me. I'm the co-founder of Banana HQ. You can find me at the rate Rishabh everywhere. And a disclaimer: things can be wrong over here because I'm not an expert in dRTC platforms and not an expert in storage proofs. But yeah, I know a little ZK. I've been working in the space for more than 2 years. So yeah. Also, a shout out to Axiom, who was important in this research, and I was able to do that research in their intensive cohort. So moving on. Yeah, so what are the goals of the talk? I'll be covering what are gated meetings, why are they important, what the hell are ZK-based storage proofs, not in detail, but yeah, I'll be covering what's a high-level overview of those things. And how are these cryptographic commitments used in making these meetings secure? So what are gated meetings? We all know that meetings are need to be gated. We cannot allow everyone to be entering into a meeting because if they do, then it will be just a crowd. And yeah, right now people are services like Huddle are using gated meetings, but they are only restricted. So a simple example can be like using these NFTs as a gated token mechanism. Whoever holds an NFT will be a part of the meeting. And yeah, this is a scenario if everyone comes to the meeting. So the current scenario is the dRTC platforms are using Oracle-based services, which are not very secure and not providing the best functionality that the dRTC platform needs. We also need complex conditions that can be implemented at the uh, gated mechanism, which allows users to hold multiple tokens or multiple NFTs in various states of time to execute or allow them to enter into the meeting. So let's say, so there needs to be an NFT over there, but yeah, cool. Let's say we have a situation over here. The user needs to have a XYZ NFT from June 2020. He needs to have at least 1,000 USDC from certain period of time to certain period. And he also needs to make certain Uniswap transactions from certain period of time. So these are arbitrary conditions, but you get the gist. We can need to provide these kind of gated token mechanisms so that we can read the history of the blockchain and allow these users to make entry into the meetings. So how can we do that? And how can do these things trustlessly without trusting any central entity or without trusting any entity in between so ever? Yeah, so here comes the ZK storage proofs. And what are they? So we can prove, like the problem in the blockchain space is that right now we smart contracts or dApps cannot access the on-chain data which has happened in the past. So what if you want to train a model on-chain? You cannot access that data on-chain, right? So we need to provide that data to the blockchain applications so that they can perform operations on that data. And how can we provide that in a trustless manner? So we can use, like I've brought out this brick from Axiom, who is working on storage proofs. So yeah, these protocols allow you to access the on-chain data and provide a proof along with the history of the data that's going into the protocol. So, and these proofs can be verified, and then mechanism can be designed to provide certain actions that needs to be taken on behalf of those proofs that the user is providing. So yeah, so here is a scenario, the landscape right now for on-chain data access. Like if you see over here, we have Alchemy Infura-based services, but these services cannot provide data on-chain. We also have services like the Graph, but the same problem. There is more trusted cryptoeconomic security, but the data cannot be accessed on-chain. The second part is the data can be accessed on-chain with Chainlink-based oracles and all these oracles, but we need to trust someone. There is no fully trustless environment. But yeah, with storage proof mechanisms, we can remove that and use services or protocols like Herodotus, Axiom, and all these things. So yeah, but how does it work? How can we integrate that? Let's see that. So here is a rough diagram that shows like how can we implement in the storage proofs in the dRTC protocols. So over here is a ZK coprocessor, which basically has two functionalities. So we write our conditions inside a DSL, and that DSL is then converted into a circuit, which basically gets the data from the user gets the excess data from the archive node, which is required to reconstruct the Merkle-Patricia tree. So in the blockchain, whenever you're making a block, or when a block is created, we have certain structures called Merkle-Patricia trees, which are responsible for storing information about accounts, transactions, and receipts. So these data needs to be reconstructed, because let's say the user wants to reconstruct data of a nonce, that you want to prove that at particular block, that's a particular nonce. We need to reconstruct that data, and we need other information to reconstruct. So that's why we are taking help of archive nodes. The tree is reconstructed, the block hash is calculated, then the block hash is proved or cryptographically linked to the current block hash, because we can only read until 256, 256 block hashes till the recent times. So that block hash is given a cryptographic link from that, and this is called a ZK coprocessor, as I mentioned. Now this calculated proof is sent to the query smart contract that's there on chain provided by the protocols. The proof is then submitted to the dRTC protocols like Hurdle. They can verify the proof, and as you can see, if it's okay, if the proof is correct, the user goes to the meeting, and if it's incorrect, he stays alone. Okay, so I mean, what are the other protocols that you can explore for the dRTC? For the storage proofs. Here are some of the protocols: Axiom, Herodotus, Lagrange, and Hyperprotocol. All these protocols are providing different mechanism of storage proofs access, but yeah, they are providing somewhat similar functionalities. So you can check them out afterwards. Yeah, I think that was a lightning talk. Thank you so much.